Donuts. What is the area of this donut? We're given, well, a circle and another circle, creating this area of a donut, and we're only given one information about it. The chord has a length of 2. This is the AB across there. With that, let's just go find the area of the donut. Well, first let's go get some labels here, okay? Let's let big R be the radius of the big circle. And with that, little r is the radius of little circle. So what is the area of each one? Well, the big circle, right, the area of the big circle is equal to, well, pi big R squared. And the area of the little circle, or the small circle, if you want to do this, I think I call it S, let's go, small, is equal to pi little r squared. And so the area of the donut that we want to find is, well, area of the big circle minus the area of the small circle, which is, as we just found, pi big R squared minus pi little r squared. And so we can write that again as, well, pull out the pi, and then a big R squared minus little r squared. All right, so basically we got to a point now where we want to just find the radius of each one of these, well, circles, and we can find area. I'm setting up the groundwork here. All right, well, tangent to a circle theorem, there's a tangent right here, it means it's perpendicular to the radius of the circle. So I'm gonna draw a radius up to that point of tangency right here, and I'm gonna continue it actually all the way to the top, as we can see. It's gonna be a right angle right here, okay? And we have a, well, let's go label this D, and I think I label that E up here, those points. Now, what can we say about point or line DB? If AB is exactly 2 units, DB is exactly in half, making it 1 unit. So put a little note here, DB is equal to 1. Well then, how can we find the length of DC? Well, we know that's gonna be, DC is our little r, that length right here. And the length of connecting here, BC, is our big R, and I'm thinking good old Pythagoras again. He always helps us out when we're in trouble. So we have 1 squared plus little r squared is equal to a big R squared right there. Now, well, if I bring r squared over here, 1 squared by itself, well, 1 squared is 1, and that's equal to r squared, big R squared, minus a little r squared. And look at that, our formula for the area of the donut here just has it informs r squared minus little r squared. And so the area of the donut, pretty easy problem, is just gonna be pi times 1, right? Because we said it's equal to 1 unit squared, or area of our donut here is just pi units squared. And isn't that a lovely problem here, that the area of our donut is pi units squared? I hope you learned something here, and as always, thanks for watching.